Welcome to our STEM talk for this evening, which is going to be hosted by David Head, who's Head of Customer Marketing at Thales Training and Simulation. Just to let you know, it's being recorded. This is so that you can access it at a later date, and if you've got other people on your squadron that'd like to watch it, it will be available for you to watch. I'm just going to pass you over. What I would say is if you've got any questions, if you can put them in the chat rather than in the Q&A. And obviously towards the end, David will take questions. And if you want to actually ask him rather than put them in chat, he will invite you to do that towards the end. Okay, over to David.
Good evening, everybody, and thank you very much for joining on this, well, it's sunny where I am, Monday evening. Hope you're all okay. So what I'm going to do is, the topic is why STEM, why science, technology, education and maths, electronics and maths, is talk to you a little bit about kind of my career before we go on and talking about specifically artificial intelligence. And the reason I'm going to do that is because I did once want to be a pilot, and that never happened. So if any of you sitting there, really want to be a pilot, and that's great and that's fantastic. But this is just to say that there are plenty of aerospace careers out there that do not necessarily mean you have to be a pilot. And I've certainly had a very rewarding and interesting career by not actually being a pilot. I've been a pilot of sorts, and I'll explain why in a minute. But I really want to talk to you about why the aerospace industry is full of careers that are not necessarily pilots. And certainly there's nothing wrong with wanting to be a pilot, but there are plenty of careers which are not pilots. So what I'm going to do is first talk about me and why STEM, then future jobs that might be out there in the aerospace environment in the future. Then I'm going to specifically home in on artificial intelligence and how that is completely changing the aerospace industry as much as it's changing the industries and the world that you live in. AI is popping up everywhere. But there are a lot of misconceptions about AI, what it is or what it isn't. So hopefully I can try and demystify some of that and show you how some of it's being used in the aerospace industry to both help pilots, but also maybe in the future do some of the more laborious tasks that pilots have to do. And certainly look at how AI can be used to inform the battle picture and help us win the wars, which is essentially why the defence industry and the aerospace industry does exist. I'll then talk a little bit about Thales. You may not have ever heard of Thales. Good if you have. Doesn't matter if you haven't. We are a big company. I'll talk a little bit about what Thales is, and then right at the end I will talk about our apprentices and graduate scheme that you can get involved in, if you so choose. And I'll give you a little link and a QR code at the end to help you understand more about careers in aerospace, careers in Thales, and get you connected for a future career at some point in the future. So as you can see on the screen there's a picture, and that is a picture of me when I was a cadet. And as you can see, I'm eagerly reading an annual. They did annuals in my day, all about the Tornado aircraft. So I had this dream. I wanted to be, a Tornado pilot. I won't bore you with the details, but that kind of didn't happen for me for a number of reasons. But what did happen for me was I joined the aerospace industry when I was very young as a project assistant, and I kind of worked my way through the various businesses, getting involved in some really interesting and really exciting aerospace contracts. From the B-1B bomber over the United States, I was doing the training equipment for that, the E-3, which the Royal Air Force no longer has, but the E-3 aircraft as well, F-16s, Tornadoes, A400M, and Eurofighter as well. So I got involved with some really, really interesting and exciting projects. All the time, I was actually still an air cadet. I carried on being an air cadet till the maximum age. I then transferred to become adult staff, and I became a gliding instructor. So for the air cadet. So I ended up, yes, I was flying a Royal Air Force aeroplane. Yeah, it wasn't quite a Tornado, but certainly it was a Royal Air Force aeroplane. And and wearing a RAF uniform as a flight lieutenant, and I'm still a flight lieutenant now as we speak. I'm on 1408 Dorking Squadron, which is in Surrey Wing. So I had a really good and interesting aerospace career, but I also married that up with having a very interesting hobby in the form of the Air Cadets and still flying airplanes. So just because I didn't actually achieve my dream of being a Tornado pilot, I've been in and around defence aircraft for all of my 36 years plus in the industry. So frankly, I've had a fantastic time, and I've really enjoyed it. But what does that mean for you? Well, if you look at the future of aerospace, there are hundreds upon hundreds of jobs. And certainly by the time you're looking to start a career, there are jobs that haven't even been invented yet, because there's technologies that are coming along which will require people to do them, create them, make them and run them, but they haven't been invented yet. So the future of aerospace is really exciting. So just to give you an idea of some of the challenges and some of the roles that you could look forward to in the future. And this is not an exhaustive list by any stretch of the imagination. But starting on the left-hand side there, sustainability is a really hot topic. So the ability to carry on doing what we're doing in the aerospace industry, but be kinder to the planet, is a massive topic at the moment. So there's lots of technologies like advanced fuels, scientists, sustainable aviation engineers. How do you make aviation more sustainable? And just to give you an example of that, you may not be aware, but the condensation trails that you see made by aircraft as they fly over your head in the nice blue sky, even those little clouds that are following an aircraft because of the condensation trail is contributing to global warming. So Thales, for example, is working on a technology that calculates what's the best height for an aircraft to fly so it doesn't produce a condensation trail and therefore doesn't create global warming. And that could be, tens of feet or hundreds of feet. So a small change in altitude of the aircraft gets rid of the condensation trail and improves the burden on the planet. So those are just some really subtle things that you could do under sustainability. Autonomous aviation is becoming a big thing. So that's platforms flying, driving, sailing, without a person at the wheel or the control column. So we'll touch a bit more on that when I talk about AI. So they're really exciting and interesting. And then moving on to the advent of electrical vehicles in the sky, vertical takeoff and landings, and urban air mobility. So you imagine those science fiction films you see where you've got little aircraft flying around in big skyscraper cities. That is coming. You only have to look at science fiction films to know where technology will go, because that's where the imagination comes from for the idea. So urban air mobility probably won't happen in my lifetime, but I suspect it'll happen in yours. But the ability to hop on a little platform and fly from one side of the city to another in a straight line or controlled airspace, all that's coming. So that brings with it, the need for pilots for eVTOLs, the ability to build little ports around the city and all the facilities that go with that, and all the technology. And then moving on to space. So space is a big place, clearly. And there are lots and lots of opportunities going to come up in space. So everything from astronauts, pilots, maintenance, space traffic controllers. Who knew that would be a thing? But if you go onto a few websites that track space things, you can see there are now millions of things floating around in space, and the ability to know where they are and control them and avoid them bumping into each other is becoming more and more an issue. So space traffic controllers will be a thing. In situ resource specialists, so that's things like mining on the moon and space mining. So if there are minerals on the moon that we need to build certain things, then we're going to need that type of person and that type of technologies. And then in the real realms of space science and fiction, cryogenics engineers, that's the ability to freeze things, stop them aging. So the ability to send people deep into space, with them surviving at the other end. All of those type of things are coming. And then moving on to just data analytics and digital twins. So you will experience data analytics a lot in your life at the moment. So every time you go on Amazon or YouTube or TikTok or walk around Tesco's with your phone in your pocket, all of the data that is being gathered by your activity is being analysed to set for trends. So it's amazing the amount of data that's being produced, and you would be surprised how much data is known about you. Not necessarily known about your name, but what you want to watch on TikTok or YouTube or Instagram or whatever it is that you do, and what you start shopping for online, is all being analysed all the time. And certainly in the aerospace industry, the amount of data that comes out of a single flight of an aircraft from A to B is huge. And if we can analyze that data in more minute detail, then of course we know more about what happened or didn't happen, and we can do more long-term maintenance on aircraft as well. And then finally on the right-hand side, so training, synthetics and artificial intelligence. These are all areas which are becoming more and more important in the aerospace industry. So the time will come, and you may not know this, but it is now possible for the first officer of an airline. So you might get on an airline going on your holiday somewhere, and the pilot at the front may never have flown the aircraft that you are on, because he's been trained completely synthetically, or they've been trained completely synthetically. And the synthetics are so good that they don't need to do any training in the real aircraft. They just jump in the seat and off they go. Just to reassure you, there's usually another pilot on there that has flown it as well. But the point is that synthetics have become so good that pilots, in the future may not necessarily learn to fly in the air. They may learn to fly on the ground. And of course, if you take something like the F-35, of which there's no two-seat version of it, then the only way you can learn to fly it is on the ground in synthetics, and then jump in the seat for your first solo in that aircraft type. So more and more things like AI specialists and machine learning, which I'll talk about in a moment, are becoming more and more needed. So that's just a sprinkling of things that are happening in the future of aerospace, all around the STEM genre. So all really interesting and really exciting stuff. So let's move on and talk about just specifically about artificial intelligence. I've picked that because, it is everywhere. It's often across the news. People worry about it. People don't worry about it. People think it's the answer to everything. It's none of those. It is a thing, and used properly, it's really, really useful. It isn't the answer to everything. But we kind of need to understand a bit more about what it is. So before we move on to AI, let's try and work out how your brain works. So either if you've got a scrap of paper near you, great. If you haven't, then don't worry, just try and do it in your brain. But if you have got a scrap of paper and a pen, what I'd like you to do is just draw those 9 dots. Give you a couple of minutes to do that. For those of you in a big room, maybe you want to do it on a whiteboard, if you've got a whiteboard handy. Just give you a few minutes to find your bits of paper, or mentally note the nine dots, because I'm going to set you a little challenge in a minute. And there's no right or wrong answer to this challenge. It's just to try and help you understand how AI works. So if you've drawn those, your challenge is to join those dots using the fewest number of straight lines possible, and no more than 4 straight lines. So think about how you would join those 9 dots with no more than 4 straight lines. I can see some people on the screen there trying to work it out. Give you a couple of more seconds. Okay, so difficult for me to ask you whether anybody's actually done it or not, but I can see one squadron's room. Has anybody done it in that room? Stick your hand in the air. I can see you. Doesn't look like it. So the first thing is that humans operate within constraints. So many of you will have taken those 9 boxes and you will have self-imposed a constraint that says you can't go outside the 9 boxes. Okay, the 9 dots. So you might have attempted to do it like that. So 1, 2, 3, 4, and of course you're missing one of the dots. So when we operate within our constraints, which is a human tendency, by the way, you know, our education, our background, our whatever it is we do puts constraints in the way of our thinking. That might be, you know, law, that might be rules, that might be dress regulations, whatever it is. Those are constraints that our brain automatically puts in place. But what artificial intelligence does is it will do whatever it likes, provided it hasn't been told it can't do it. So, for example, you can do it like this when you think outside the box. So just moving outside the 9 dots, you can do it. You can join those 9 dots with 3 lines because you've gone outside of the box. So if anybody did it like this, great. It means you've got a slightly different brain pattern than others. You may be a little bit of a person who likes to operate outside the thinking box, and so you do that. But of course, if you have no constraints, which is when you start AI running as a thing it's trying to learn, you can do it like that. Because I didn't say how big the line had to be or how wide the line had to be. I just said it had to be some straight lines. That's a straight line, and AI would eventually do that. So I'll explain why AI would do that. So at first creation, AI agents are like children. So you know, popular misconception is that some clever scientist somewhere is writing an AI algorithm that can do everything or nothing. And that's not true. The reason it's called artificial intelligence is because it creates its intelligence itself. All an AI engineer will do is write an objective, i.e., what do we want the AI to do, and what are the constraints? Okay. So what can you not do? So, for example, if you were doing a drone or something with AI, you might put a rule in there that says, must protect human life, as an example. And so, therefore, any drone, for example, that's got that AI algorithm won't attempt to harm human beings. So they're like children. So, when we all came into the world, we didn't know how to walk or talk. And over time, we've learned how to walk or talk. That's exactly what AI is like. You put an AI agent into a machine learning environment, and then you just let it run. So the scenario I just showed you with the nine circles, you would just let it run. Trying all possible permutations of doing straight lines. And because we hadn't put the constraint in about being outside the box or how big the line would be, eventually AI would come up with all of the possible permutations of answering that particular puzzle. So they do it like trial and error. And the reason that you can do that is because if you try to program, let's, for example, say you wanted to program that drone to do a particular approach to a particular airport. If you had somebody sit down and write all the possible permutations of how to do that, it would take a very, very long time to do it. But if you create an AI agent where the objective is to land at a certain airport, and you give it constraints, and then you let it go, it will learn millions upon millions upon millions of time in a very short space of time. So you might leave it running for 2 or 3 days, and it would learn every possible permutation of doing a particular approach. And that's called reinforcement learning, which is a form of machine learning. So you give it a goal, that's the goal. You give it an environment, so you tell it what type of environment it's in. And then most importantly, you give it constraints. You don't say, you don't give it free rein, because if you do, you'll end up with an AI that will do things that you don't want it to do. And some of those constraints might be physics themselves. So in a synthetic environment, if you don't tell them, how much gravity there is, or what way up is, or how dense the air is, then it will assume that it's completely open, and therefore you'll end up with something that doesn't fly correctly. And essentially, and this is very important, the longer you let that AI learn, the better it will be. So if you stop it learning at a certain point, it might be like, they've just finished their GCSEs, for example. They've learned that much, and that's as far as they've gone. But if they keep going, it will do its A levels. It might go on to do a degree. As a good analogy, it will keep on learning. So in the combat world, for example, if you want to teach people to fly, then you want to understand how good an AI is. So you might stop it earlier. If, however, you're trying to work out how your enemy might possibly react in a certain situation, you might keep the AI learning so that you can learn all the possible permutations of a given scenario. So I'll come back to that in a minute about how much you let something learn and what level of intelligence you give something. But if you imagine an AI, just to summarize that, an AI starts as a child, it knows nothing, you give it an objective, you set some constraints, you put it in an environment, and you then let it learn, it will carry on learning until you stop it at the level you want it to get to, or let it go on forever if you want to find out absolutely every possible permutation. So that is kind of how AI's basic form kind of works. So just to talk about those constraints, for example. So hopefully you see this video. Hopefully it'll run over your bandwidth. But this is a drone. This is a Thales drone, and you can see that it skips occasionally. And that was because we were doing some trials as to how we could train a drone using AI to do certain things. But what we found was, in that great big data gathering, there were holes in the data. So we needed to use AI to fill those holes, so fill the gap of the data. But this constraint we had to put in there was, well, what's the physics? And that's where you get something called physics-informed neural networks. Big fancy phrase, but basically it's telling AI, don't do something that is against the laws of physics, and you put what the laws of physics are in there. Otherwise, you end up, as you can see on the screen here, it flies reasonably okay, and then every occasion it jumps because there's a hole in the data, and the AI hasn't put correctly physics-formed data in its place. So that's kind of one of the constraints that you have with AI. You've got to tell it about the world of physics. So the other thing that Thales has been playing around with is, can you create an AI that can accurately fly an aircraft without it ever flying that aircraft? So what you see on the left-hand side is actual aircraft data and the actual performance of a given aeroplane. I won't say which airplane it is. And on the right-hand side is the one that AI has learned. So all we've done is we've given the AI the flight performance of the aircraft, what it can and can't do. That's the constraints. We've put it in an environment, and we've said, go learn what to do. And as you can see, it's a pretty accurate representation of what that aircraft can do. But no one has written the code on the right-hand side. That's the important thing to remember. So for those of you who do online gaming or games where you've got aircraft platforms in it, most of the current games online are using coded algorithms to fly aircraft. i.e. they're running to a set pattern and someone has sat down and coded that. There are a few, but not many, where you've got an AI agent which allows it a lot more free and accurate flying. So, it's a little bit like non-participant players in games, where they're just on a set loop doing a set thing because you've got a set of codes. Whereas AI is a lot more freeform and will react to its surroundings and change because it knows a lot more. It's probably got millions of scenarios, whereas an online game's probably got maybe 100 or so. So that's kind of the difference between where AI is getting to versus the gaming world. And then, of course, once you've got that information, you can tell AI to go do something. So, this particular video here, we didn't tell the aircraft how to fly between the loops. We just said, fly through the hoops, please. And in this order, and it's worked out itself how it's going to fly through those hoops. So nobody programmed this, AI did it itself. Go fly through the hoops, off you go. So it's done it itself. And that's how AI works. And then how can you use that AI to help pilots fly? So obviously, most pilots have instructors, but when you're strapped for instructors like the Royal Air Force is currently, they're short of instructors. If you can have any form of AI assistance, then that's really useful. So if you've got a software package in an AI agent that knows how to fly and knows how to do a loop, the AI can be monitoring the pilot and how well they do. So on the screen there, you can see that aircraft flown by a pilot has done a barrel roll, and the AI has measured how well it's done that barrel roll. So it's given it a score of 81 out of 100. And in a second, I think it does the loop as well. So AI knows how to do a loop. It knows what the optimum way of doing the loop is. So it's monitors what the pilot has done. It can feed back immediately to the pilot. Yeah, you did the loop okay. So the instructor doesn't even need to be in the aircraft because the AI has told it how well you've done the loop. Now, of course, that doesn't include good things like lookout and airmanship and monitoring the engines. That's just a single reference data point. So you have to do other things like monitoring eye patterns, where a person's looking, and all things like that. And all that technology exists. But in its basic form, AI is able to now monitor how a pilot is doing against a given set of maneuvers. And of course, this is free fly. So AI didn't know that it was going to do a barrel roll. It just worked out that was a barrel roll, and this is how well it was doing. And so now we're going to move on to computer-generated forces. So this is getting into the realms that perhaps might be a little bit more familiar to you. So this is, to all intents and purposes, wargaming. We'll call it that. Obviously, this is for a serious purpose rather than gaming online. But if you want to send your crews to learn how to go into combat against many people, that's quite costly in terms of somebody writing all the parameters for the enemy to do certain things, or somebody flying all the enemy aircraft, because it takes a lot of time and money. Also, if you've got scripted behavior, and you will do this with online gaming, you kind of learn quite quickly how to beat the enemy. That's how you can move from level to level, because a given enemy is going to do a certain thing, because it's quite constrained by how much it can do, because someone's programmed it. And if there's only sort of 10 or so options, then you learn how to beat your opponent quite quickly. Whereas if you've got an AI agent that's done it millions and millions of times, you can't do that. You can't possibly know that this time it's going to go left as opposed to right, or up instead of down. So that's why AI is really important in this particular scenario. So if you can find a way of creating computer-generated forces, i.e. enemy, that are not manned, that are very realistic in terms of how they might react, then you've got a really good environment in which you can train your combat pilots. So this is a little, we'll call it a game. And for those of you at the National Air and Space Camp last year, we had this actually at the Space Camp. I'm not sure whether we're taking it this year or not. I don't know. We've moved it on from this version, but we may be. So this is just a little scenario that we've created to test how AI may or may not operate. So the aircraft at the top are all AI, the purple ones, and the blue ones are all the ones at the bottom, and they're humans. And our AI at the top are really, really very good. You can't beat them. And I'll talk about skill levels in a minute. But we can change those skill levels and how much they know. But you can see that unfortunately the blue team is pretty much done. They will be soon. And Goose has just gone, but then he always goes. So those of you who watch Top Gun, Iceman's still alive, but is about to go, because the AIs that are flying the purple, as opposed to the humans, which you can see in the bottom right hand picture there, are really, really good. So looking at the screen, if you look at the top, it says skill level 100%, that line at the top of the screen on the right hand side. That's because we've got AI set to 100% of its knowledge. So that means we've run the AI algorithm for a very long time, and they've become really very good at being air combat pilots. So of course, teaching people air combat against an impossible enemy, impossible to learn, isn't very helpful, because you're just going to get shot down every time. So having that skill level where we can wind back the AI so it is less capable is really, really important for learning. So on this particular scenario, you will see it says 100% at the moment, but we wound it back to 70%. And therefore the win probability, which is this in the screen, this purple bit and the green bit, it shows you who's more likely to win in the probabilities. So purple is smaller this time, and the green blue bit is a bit better, because we've turned down the AI. We've allowed the humans to be a little bit better versus the AI. And as you can see, we're about to take out a number of the purple ones, but that's simply by changing the skill level of the AIs, and we can wind it all the way down to sort of very low percentages if you've got new combat pilots learning what to do in a combat scenario. And obviously this is set in 2D because it's just easier to show on the screen, but obviously it is in 3 dimensions in the real tool. So wouldn't it be helpful though, if you were a pilot, if you had all the knowledge and the skill that the AI does have? So another thing that AI can be used for is, having taught an AI how to be the best combat pilot you possibly can be, you can then give that information to your students. So if you look at the screen now, you can see that the aircraft have what look like a water spray in front of them. And what that water spray is doing is giving information to the crew as to what to do. So most of the time it's currently saying, go straight ahead. But you can see one of those there, the water spray occasionally splits in two, and it says, in this particular situation, you might be better off going right or left. So the one that's now turning hard left, is following that water spray. And the different colors of the water spray are telling you when you're in a danger situation, or when you're in a good situation to fire a missile. So what we've done there is we've flipped the AI. So where the AI is not trying to shoot you down, the AI is now trying to help you as a student to be the best combat pilot you possibly can be, by taking all of that knowledge that AI has learnt, putting it in the cockpit in some form, either into your head-up display or into your goggles, and giving you all that information to know how to beat your enemy. And of course, at the end of that, back to sort of data analytics, you can plot all of the activity that occurred, and a little bit like the old Top Gun debriefs, you can go back and look at how well you did or didn't do in the scenario. So whilst that looks like a bit of a spaghetti mess on the screen here, obviously you can hone in on the details specifically to what you want to do. And then lastly, the other thing that's useful to know, and AI is useful to help you with, is what is the cognitive load? Well, cognitive load is how hard are you working? How many brain functions are you using in a given scenario? So if you look at the big band on the right-hand side between the two aircraft lines, you can see that it's pretty much flat line at the moment because they're a long way apart from each other. But as they get closer, the various aircraft's cognitive load, the amount of brainwave activity that's going on increases. So that uses AI to work out, how fast do I need to process information? How much do I need to work on a certain thing? Because how hard is my brain working at this particular time? And of course, we're all different. All humans are different. We all process at different times. So having this information is really, really useful feedback for crews to say, this moment in your combat is your most highest stress point, and then using things like heart rate monitors and perspiration monitors, we can work out how good a combat pilot is going to be in a stressful situation, because it is a stressful situation. Even for the best pilots, it's a stressful situation. So having all of this data and AI monitoring you is a really, really helpful thing to do. So I'll just, in summary, just let this run through. This is kind of the whole piece. You can see we've used AI to teach people how to fly. So there's some of our engineers. They do real work. They don't just play games all day. But that is one perk of the job. We do win probability prediction. We can look at tactics. What's the best thing to do? We can look at course and action analysis. There's a whole bundle of things we can do with this particular tool, either in simulation and training or in the real aircraft. We can look at how much the brain should be working in this given scenario. And we can look at how best to communicate. Because the other thing that the AI is doing in this particular scenario is those 4 aircraft, all the 4 purple ones, are still communicating with each other. They are working as a team. They are not working as individual AIs. So they are talking to each other in a language they understand. And we can do things like situational awareness as well. So all useful things using AI in the training world. So just to summarize on the AI then, what could AI be used for? Well, we can use it for fully immersive, human realistic training environments. So we can scale it for difficulty and outcome. So obviously the ab initio early pilots, you want to make it quite easy for them and then slowly build up the capability. So you'd probably use offline machine learning, reinforced learning for that, because you want to stop the ability of the AI at a certain point, because you want to be able to control it. We can also use it for synthetic design environments, or some people call them digital twins. And that's when you might want to test certain equipment testing, do concept of operational analysis, doctrine, rehearsal, enhancement. And you possibly want that machine learning or reinforcement learning to go on continually, because you want your AI to be the best it possibly can be, because that's how your enemy might be. And your enemy might work out a way to beat you that you don't know about. So the more the AI does, the more chance you have of understanding every possible permutation. So in that type of scenario, you might want the skill level to go on ad infinitum. There's programming in the Royal Air Force at the moment called the Autonomous Collaborative Platform. So that is, there'll be an F-35, for example, will go into combat, and alongside it, it will have what are called loyal wingmen or autonomous collaborative platforms. So they're unmanned platforms, but they're working as a team with the F-35 pilot. So that needs a level of artificial intelligence, because the pilot can't fly more than one aircraft. So the aircraft has to fly itself. All the pilot needs to be able to do is direct those autonomous collaborative platforms to what they want to be able to do. AI instructor is one I've already mentioned. We saw the little diagram there of monitoring a loop or a barrel roll. and an autonomous tactical aid. So a little bit like Siri or Alexa or whatever you use these days, where you can ask your AI a particular piece of information, and it comes back with all the tactical information that you need, rather than you having to search for it. So that's another potential use for AI in the aerospace industry. So that's just a very quick canter through a very difficult, very complicated subject. Hopefully you understand a little bit more about what AI is, and what it's not. Um, and that can be useful in helping you decide whether, you know, the AI scientist role or something like that is something that's of interest to you, because it's really interesting. I don't do that work. I've got a team of engineers that do that work. It's my job to market the work that we do, and hopefully customers buy it, which they do, which is good. So now I'm going to move on to early careers in Thales. But before I do that, I'll just say a little bit about who Thales are. So Thales is a French government-owned international company. So we're owned 39%, I think, by the French government, but we are an international company, and I work for Thales UK, which is a UK profit and loss company. So it's one of these companies kind of so big you never heard of it, but we've got 83,000 employees across 68 countries, and we invest 4 billion euros every year in R&D. So all of the things you just seen, the AI stuff, you know, that's part of that investment that we're working on, the technologies, and we make on average about 20 billion euros a year. So a big company, by anybody's definition. And we work in 3 sectors. So aerospace and space, defense and security, and cyberspace and digital identity. So to give you an idea of the aerospace stuff, at any one time in the world, about 75% of all aircraft in the sky are being controlled by a Thales radar system. That gives you an idea of where we are in the aerospace industry. In cybersecurity and digital identity, I guarantee you that your mobile phone has got a chip in it from Thales, the same as your passport. Your ID passport is made by Thales, and the biometrics in that is a Thales product. Your credit cards, if you have them, again, they have chips in them, and they're Thales things. And defense and security, I can't talk too much about what we do in that, but we do a huge amount. We don't make aircraft, that's one thing Thales does not do, but a lot of the critical systems that go onto aircraft for defense, offense, are made by Thales, right across the world, not just in France or the UK, but right across the world. And we work for enterprise customers, governments, institutions, and cities around the world. And just to give you an idea of where we are in the UK, so you guys are all from across the UK. So if you're thinking about a defence and aerospace company you might like to join, then there's pretty much an office near you, I am sure. You can see we're spread right from Scotland through Northern Ireland, all the way down to Cornwall and the southeast of England. And there's about 7,500 employees in the UK, of which 4,500 are engineers, and we do have a really good graduate and apprentice scheme, which I will talk about in a moment. But in the UK, we make about 1.6 billion of revenues. And social value, as I mentioned right at the start of this, sustainability is one of our big things. So the ability to make the world safer, cleaner, and greener is one of the mantras that Thales does. So a lot of the stuff we are doing is working towards net zero. Like example, I've mentioned the contrail piece as well. So if what I've talked about this evening has been of interest and excitement, then there are opportunities for you when you get to the time in your life to come and join Thales, either as an apprentice or a graduate apprentice, and in lots of different areas. So obviously engineering, IT, manufacturing, cyber, finance, project planning and controls, procurement, data and digital are just some of the areas where we offer apprenticeships. And for you, if you are already in your first year of GCSEs at the moment, then you can apply to become a graduate, an apprentice in October of this year. So I'll give you a QR code in a minute where you can go and get more information. And that will be for roles starting in September, which is after you've finished your GCSEs. So if you're sitting there thinking, I don't know what I'm going to do, it might be an interesting career for me to look at, then I do thoroughly recommend you go look at the website I'll show you about in a moment. And then graduate programs, so to similar timeframes, but graduate programs at Thales offering an engineering, system, software, and mechanical, procurement, contract management, bid and project management, and business growth. So obviously we're talking about STEM a lot tonight and the technical side of it, but there are a lot of what I would call ilities that are also important in the aerospace world. You can't do the type of programs we do without having good procurement, contract management, bid and project management. And that's kind of my career. My career was project management. It was not engineering. I dabble in engineering because I have to as part of my job. But at the bottom line, they are all important roles within the aerospace industry. So not just STEM, there's other things as well. So again, if you have completed your relevant degree within the last 5 years, or you're due to finish in the summer of 2025, then you can apply in October for a graduate role. And some of the stuff the graduates get to do with our company are quite amazing. They get to move around most of Thales, sometimes internationally. I've said we operate in 68 countries around the world, so their career opportunities are huge for both apprentices and graduates. So if you are interested in looking at more information, then there's a QR code on the screen, which I'll leave on while we do Q&A as well in a moment. If you download that QR code, that will take you to the Thales Future Talent Connector platform, and on that platform you can look at, without any commitment whatsoever. Just because you've downloaded it doesn't mean to say you're going to become a Thales member. It just means you're interested in it. You can register your interest, and then you'll get all the information you need to inform a decision about what you do or don't want to do. But you can also connect to current apprentices and graduates on that platform and ask them what they think. Ask them whether they're enjoying it, whether it's been useful. And the majority will probably tell you that it is. Obviously, there'll be one or two that it's not for them, but generally our apprentices and graduates get around a lot, do a lot, and many stay with the company for many years. So that's that QR code there if you want to use it. I think that takes us nicely to Q&A, and that's the QR code there as well. So I'll leave that on the screen. So Q&A. Lieutenant Russell, were you going to?
Do you want me to read the questions out, or?
Okay, I'll do it myself. So a question there. So how do you stop AI learning? You simply switch it off. It sounds too simple, but that's it. If you've set AI a task, go do this as many ways as you possibly can. You set it going, and then you can set how long that will go for, and therefore you then just stop it at a given point. So then the algorithm that comes out of that, at which point it stopped learning. So you just stop it learning. Then if you're going to put it into a synthetic environment for training, you won't let it learn again. You'll just let the executables run, and it will do its thing, and you can wind the level of learning up and down depending on what type of training you're doing. If, however, you're doing experiment, then you might want it to carry on learning in case you do something that it goes, aha, I can do that better. So generally you operate in two ways: one where it's continually learning, and one where you can control its learning. Next question: Do I think AI will be future humans? Difficult one. So I'm going to say no, because the one thing that AI is not good at, I'm not saying won't ever get there, it's not good at it. It is not good at emotion. So I'll give an example of that. They did an experiment with AI doing an editorial of a Hollywood movie. So gave AI all of the scenes, all of the uncut scenes of a Hollywood movie, and it said, go edit the movie, go make the. And what it did was it did really well at doing the plot. It understood the plot of the movie. It got all the scenes in the right order. But then when it came to putting the music onto the scenes, it completely messed it up. There was no emotion. So you had a happy scene where there was doom and gloom music playing, or you had someone being stabbed and murdered when there was jolly music playing. So AI is not good at human emotion. And what I would say about AI is that even in the stuff that we're doing with combat scenarios, you still need a human in the loop, because humans have an emotion, they have an intuition that AI doesn't get close to at all. That's my opinion. I'm not an expert in it, but I think that that's one of the big drawbacks. AI does not have emotions. How will AI be the end of humans if AI are set to follow a designated algorithm set by humans? Not sure I entirely understand the question. How will AI be the end of humans if AI are set to follow a designated algorithm? Well, if your answer is, are we going to end up in Terminator territory? Then the simple answer is no, because we are controlling what AI can and can't do quite carefully. So I don't believe that AI will be the end of humans. Is my personal opinion. Someone said, so like when Alexa says, you say stop. Yeah, exactly. Yeah, so when Alexa goes off on one and you're going around in a loop and not answering your question, which is really annoying, you just say stop and it just stops. So in future, will AI ever be able to design working planes? Yes, I think they will. And a lot of the stuff we're doing in digital twins is about that. It's about seeing what you can and can't do with platforms. So I think yes, a lot of design work will be done by AI in the future with a human oversight. It's not going to be this aircraft has been designed AI full stop. It's going to be the basics of the design might be done by AI and then fine-tuned by a human. Will AI ever be able to get around the constraints given to it? Yeah, potentially yes. I've not seen any examples of it yet, but much of it is. I would say, if you're concerned about getting into Terminator territory, is AI safer than some lunatic who gets hold of your capability? And I would say probably no, AI is not more dangerous than that. So no is the answer. So I think I've answered that one. So Carl Bowie, in the future, will AI ever be able to design working planes? Yes, as I say, yes, I think yes, they will be able to answer and design working planes, but not necessarily the entire thing. AI will be a very useful tool. So if you enter the aerospace industry and you're privileged enough to work on the future generations of aircraft, then I think AI will be something you will use an awful lot. And a little bit like you might use ChatGPT now. You might use AI to go and write the basics of your essay, which you shouldn't do, by the way, because it's cheating. But if you do, then you're going to take the basics of it and then you're going to rewrite elements of it on it to make it your own. So in the same way as AI could be used for designing working planes, then someone's going to step in and refine it and retune it. When will pilots be taken over completely by AI? That's a really interesting question. Depends in which context you're talking about. If you're talking about the civilian world, i.e. airliners, I don't think they ever will be overtaken by AI. And the reason I say that is your average general public person will not want to get on an aircraft where there is no human at the front making the decisions. So in theory, the technology for an airliner to leave the departure gate, take off, fly to its destination, land, and return to a departure gate on its own, in theory, that technology exists today. But aviation regulations require there to be 2 pilots. Fare-paying passengers expect there to be 2 pilots. The big debate going on at the moment, could you drop that to 1 pilot? Maybe at some point in the future. But you've then got the redundancy issue of what if that pilot falls sick or ill or incapacitated in some way? You're then left with AI. So I think in the fare-paying passenger world, I don't think you'll ever end up with completely AI-driven aircraft. In the combat world, certainly you're going to end up with pilotless drones, but they'll be operating in concert with a manned platform, a human in the loop platform. And again, for the reasons I've said, in the chain of command, I believe there will always be a human. I do not think that various regulations and things will allow us to operate AI completely. So I think generally, I think it's a long way off before it's completely AI. Might come eventually, but again, not my lifetime. But I think we're a long way off of that. So panic thee not if you're worrying about it. But also, if you want to get into the industry to make good stuff happen, then I thoroughly recommend it. So I think that's all of the. Thank you, 310 Squadron, for your comment. I think that's all of the comments on the chat room. If anybody wants to open their mic and ask me a question, then feel free to do so.
We'll take it from the silence that everyone's had their questions answered.
In which case, I'll hand you back to Flight Lieutenant Russell.
So thanks very much, David, for your time this evening. Obviously a very interesting talk and lots of information about Thales as well. Can you hear me okay? Not sure if my mic's working. David, can you hear me or not?
You may be on mute.
Can you hear me now? Oh. Oh, right. So they can hear me, but you can't hear me.
Still can't hear you. Your box is lighting up. I can't hear you.
I'm just going to call it a day, but thanks for your time.
I can hear you now.
Okay, just miraculously. Just want to say, David, thanks for your time this evening. Obviously, really interesting to find out more about Thales, a company maybe some of these cadets haven't heard about before or not enough information about them before. There's obviously lots of opportunities within aerospace industries and obviously industries that use AI. Just thanks so much for your time. And we'll just call that a day. Thanks very much, everyone.
Thank you.
No problem at all. Thank you. Let's end the event. I think they will slowly start leaving.